Now coming to the direct linking loader. So this direct linking loader is nothing but a general but relocatable loader which is commonly used loader of today. So this loader cannot have direct access to the source code, and then in order to place the object code in memory, there are two options which has to be performed during the operation of loading. Firstly, either the address of the object code should be an absolute and which can be directly placed into the memory. And secondly, the address is relative, then it is the assembler which is going to inform the loader about the relative address. And this loader has the advantage of allowing the program in order to perform multiple procedure segments and also to perform multiple data segments by giving them the freedom of referencing the data as well as instructions which are contained in other segments. So this provides the flexibility in order to perform the inter-segment referencing as well as accessibility in order to perform the operation at the same time and allowing the independent translations of the programs. So this provides the flexible inter-segment referencing and the there are basically four object decks which the assembler provides for the loader. So they are nothing but the external symbol dictionary, that is an ESD card. So this ESD card provides the information about all the symbols that are defined in this program but may be referenced in the program but defined elsewhere. The next is a TXT card, that is TXT, which records the control of the object code which is being translated into the version of the source program. And then the third one is relocation and linkage directory, which we call it as an RLD card. So this card combines or contains the information about the location in the program whose contents depends upon the address at which the program is being placed. And lastly, the end card, that is called as END. So this indicates the end of the object file and then it specifies the starting address of the program for execution. And then the text format of the database. So this text contains the reference number, the relative location or their relative address as well as the object code. Now the reference number which is being specified for all the text is being jotted out into the table along with the relative address, and then the program, that is the instructions which are going to be specified along with the reference number, are being specified into the text table. Now coming to the format of the databases, the ESD card. So this ESD card contains three types of definition. One is called a segment definition, local definition, and the external reference. Now as you see in the table, we have the 5 columns. The first one is the reference number, second is the symbol name, third is the type, fourth is nothing but the relative address, and then the length. So if you observe in the table, the reference number 1, which contains the symbol or the label name as John. John is nothing but the name of the program. This identifies the type which has been called as the segment definition, or which defines the segment definition, and the relative address is nothing but the starting address of the program for John. So this relative address is being specified with the length as 64. Now coming to the reference number as 2, the symbol is being identified as result and the type is called as the local definition, which contains the relative address as 52. So similarly, with the reference number as 3, we have the symbol called as sum, and this identifies or represents the type as external reference, which is being used externally and which does not have any relative location as well. The RLD card, it includes different operations that are to be performed with respect to it, and also the flag is important in this table. The relocation card, that is RLD card, has the following information such as the location of each constant that needs to be changed due to relocation, and also by what it has to be changed and the operation that has to be performed. So the format of the databases which is being given in the table, such as the reference number, symbol, flag, length, as well as the relative address. So if you observe in the table, we have the reference number, that is nothing but the card number, as 14, which contains the symbol, the name of the program such as John, and then the flag is being represented as plus, and along with that it specifies the length of the symbol, and the relative address is being specified as 48, which is being identified at the card number as 14. So similarly, the reference number 17, we have the relative address location as 60, and then the length to be specified as 4. The symbol is identified as sum. And then we have the end card. The end card is nothing but the last card which identifies the end of the program. And then the text format of the database. So this text contains the reference number, the relative location or their relative address, as well as the object code. Now the reference number, which is being specified for all the text, is being jotted out into the table along with the relative address, and then the program, that is the instructions which are going to be specified along with the reference number, are being specified into the text table. Now what are the advantages of direct linking loader? It's nothing but one of the popular loading scheme which is presently used, and also it allows programs multiple procedure segments and data segments. So it allows the programmer to have freedom in referencing the data or instructions contained in other segments, and also it provides flexible inter-segment referencing and accessing. The disadvantages of the direct linking loader is nothing but it is necessary to allocate, relocate, link and load all of the subroutines each time in order to execute a program. Since there are many and hundreds of subroutine programs involved, especially when we include the utility subroutines such as square root, etc., this loading process can be extremely time consuming. So because of that, even though the loader program may be smaller than the assembler, it does absorb a considerable amount of space. So these problems can be solved by dividing the loading process into two separate programs called as a binder. Now what is a binder? A binder is nothing but a program which is going to perform the same function as the direct linking loader in binding the subroutines together, but rather than placing the relocated and linked text directly into the memory. So what it does is it outputs the text file as a file or as a card deck. So this output file is in a format ready to be loaded and is physically or typically called as a load module. So the binder essentially performs the function of allocation, relocation and linking, whereas the load module or a module loader physically places the load module into the core or performs the function of loading. There are two major classes of binders, that is nothing but image builder and linkage editor. So what is this image builder? The simplest type which produces a load module that looks like a single absolute loader deck is nothing but the image builder. That means the specific core allocation of the program is performed at the time the subroutines are bind together. So this kind of module will look like an actual snapshot or an image of that particular core of a core, and this is called as core image module, or it is also called as an image builder. Now coming to the linkage editor, this linkage editor keeps track of the relocation information so that the resulting load module as it assembles can be further relocated, and thereby it can be loaded anywhere into the core. So in this case, the module loader must perform additional allocation and relocation along with loading, but it does not have to worry about the complex problems of linking. In the previous loader schemes, we have assumed that all the subroutines needed are loaded into the core at the same time. So, in case if the total amount of the core required by all these subroutines exceeds the amount which is available, and it is been common with most of the large programs in case of the small computers as well, then there will be a problem which arises so that these problems cannot be solved. So similarly, there are several hardware techniques such as the paging segmentation that attempts to solve this problem. So in order to perform all these operations, we go with the dynamic loading scheme upon which the binder is being used in order to perform the dynamic loading. So as you see in the figure, we have 5 subprograms A, B, C, D and E, which require a complete of 100 bytes of code. So the arrows indicate that a subprogram only calls B, D as well as E, and subprograms C and E do not call any other programs. As you see in the first diagram, that is the overlay structure, we have A, which is going to call B, D as well as E, whereas B calls the programs C and E, and D alone calls E. So here C and E does not call any other program. Now if you observe the second one, that is the figure which shows the storage assignment for each procedure consisting with the overlay structure. How exactly each of these programs are being overloaded or loaded onto your core. So in order for the overlay structure to work, it is necessary for the module loader to load the various procedures as they are needed. But there are many binders capable of processing and allocating an overlay structure. The portion of the loader that actually intercepts the calls and loads the necessary procedure is called an overlay supervisor, or simply the flipper. So the complete scheme is called as a dynamic loading, or it is also called as load on call, which is nothing but load. There are major disadvantages when compared to the previous loading schemes is that if a subroutine is referenced but it is never executed, then the loader still has to incur the overhead of the linking of the subroutines. Further all these schemes require the programmer to explicitly has to name all the procedures that he has to call. So because of this, a general type of loading scheme is required, which is called as dynamic linking. So what is this dynamic linking? Dynamic linking is nothing but a mechanism by which the loading and linking of external references are postponed until the execution time. That is, the assembler produces text, binding and relocation information from a source language DEC. So the loader loads only the main program. If the main program should execute a transfer instruction to an external address, or if it has to reference an external variable, the loader is then called. Only then this segment containing the external references is loaded. So this dynamic linking, it lets the several programs to use a single copy of the library code. Now the main advantage of using this dynamic linking is that there is no overhead which is incurred unless the procedure to be called or referenced is actually used. The other advantage is that the system can be dynamically reconfigured. So the major drawback of using this type of loading scheme is that overhead and complexity incurred due to the fact that we have postponed most of the binding process until the execution time.